Hi, and welcome to question one of the 2024 Junior Cert Higher Level Maths paper. So question one is around probability. The question reads, Bia has 8 numbered counters. There are 4 red counters numbered 1 through 4, and 4 blue counters numbered 7 to 10. So Bia picks 1 red counter at random and 1 blue counter at random. Then in part A is asking us to complete the table to show all 16 different pairs of counters Bia could pick. One has already been done for you. So the one they've done for us is the counter 2 and 8. So they give us this kind of grid where we can just match up the numbers. So it's actually fairly handy. I'm not going to bother writing it in and get the answer done out. So you see there, 1 goes with 7. R1 goes with 8. So you see them here. 1 goes with 9. 1 goes with 10. Okay, so just continue on in that vein, okay, and it's fairly straightforward. Now I usually have the marks for the question up here, but I'm making this before the marking scheme is being released. So you can always get marking schemes from examinations.ie, or look, if you have the exam papers from any of the companies, should have them in there as well. So part B then says find the probability that one of the counters Bia picks is a 7. So probability of an event can be given by, now I often don't remember this formula, but I always put it into a simple situation of, if you're rolling a dice, how many possible outcomes can happen or things can happen. Okay, the number of them. Or on the top is what actually happens. Okay, so in this situation, how many counter combinations are there? Well, if you count in the table, on the bottom there's 16. Now, how many actually have a 7 in them? Okay, well, there's 1, 2, 3, 4. I look through the rest of them and I don't see any other 7, so it's 4 over 16. Now, that should get full marks, but we always should leave our answer in the simplest form. That's the same thing as 1 over 4. Now, you can always put it into decimal, but that's a bit overkill. And we might make a mistake is by giving that as a percentage. Okay, 0.25 times 100 is 25%. But they're not asking for percentage probability, they're asking for probability. And probability always scores between 0 and 1. If your answer is bigger than 1, it's wrong. If it's negative, it's wrong. Now, part C says list the pair of counters where both numbers are prime. Now, prime number is only divisible by itself and 1. Okay, so you can nearly write out the first few primes. Okay, so like 0 is not prime, 1 is prime, 2, 3, actually is 1 prime. Actually, 1 is not prime. What am I thinking? 1 is not prime, even though it can only be divisible by itself and 1, because they're the same thing, it's not considered prime. So it's 2, 3. Now 4 is not prime because it can be divided by 4 and 2 and 1. 5 is prime, etc. Okay, so you could like list some of the prime numbers, okay, if you needed to. The opposite of a prime number is a composite number, which is basically every other number. Okay, although they usually focus on asking about primes, and mathematicians love prime numbers for many, many reasons. So if I look of all the numbers there, let's clear off all the writing. Okay, actually, let's go straight to the answer. If you look at it, which counters contain a prime number? Well, like these don't have a prime number. That's not prime. That's not prime. That's not prime. That's not prime. Now, that's not prime. That's not prime. All these aren't prime, and 10 is not prime. So the only ones that have both numbers are prime would be these 4 here. But then if you look at it, 1 is not prime, and 4 is not prime. So you're left with 2, 7, and 3, 7. And that's it. Okay, so that's the end of question one. As always, if you want a copy of these notes, just send me an email at shanetroy@gmail.com or like and subscribe to get access to more playlists. See you on question 2.